So we're going to talk about log graphs. So one thing that's going to help you out with graphing log functions is thinking back to the relationship between logs and exponentials. So inverse of the exponential, okay, if I have a graph y equal 2 to the x, the inverse of this is y equal the log base 2 of x. Okay, so you think about the graph y equal 2 to the x. This is a growth function. A, your base, is greater than 1. So we're passing through at 0, 1. We're growing. Each day we're doubling. So each day you go out, you get twice as big. The domain is negative infinity to positive infinity. The range goes from 0 to infinity. Now, that's y equal 2 to the x, right? So now what I want to do is I want to do the inverse. The inverse is reflected across the line y equal x, okay? So we're reflecting across the line y equal x. So now what we're dealing with is y equal the log base 2 of x. So every x becomes y and every y becomes x. So instead of 0, 1, what do we have? We have 1, 0. Okay, 1, 0. Now, instead of my domain being all real numbers, my domain is my range of this first function. So the domain goes from 0 to infinity, so it's only positive. And the range becomes all real numbers. So the domain and the range swap for the inverse. So what does this look like? My graph looks like this. Okay? So this is the idea here. This is a logarithmic function is going upwards towards infinity as we go to the right, but it's just going at a really slow rate. Okay, it's going at a really slow rate. It's not exponential growth, which is going up super fast. You know, the idea here is it's reflected, okay, about this line y equal x, right? So let's try and well, let me give you one more. So y equals e to the x. Remember, e is this special number. Like if I typed in e, I get like 2.7172 so and so, right? So y equal e to the x. This is an exponential growth function. Okay, that's y equals e to the x. The inverse, remember, we flip it across the line y equal x. Okay, so what does that mean? That means x equals e to the y. Well, how do I solve for y? I have to natural log both sides. If I natural log both sides, I get ln x equals y here. And so the natural log function, y equals ln x, the inverse here. Okay? So one thing to note is that 0 and negative numbers are undefined for logs. Okay? So if you think about it, the domain here are only positive numbers. So if I try to plug in 0, okay, look, for the exponential, we talked about there being a horizontal asymptote y equals 0. Well, the inverse, x becomes y, so now all of a sudden we have a vertical asymptote, x equal to 0. So we can't plug in 0 here, just like we can't plug y equal to 0 in for our exponential, we can't plug x equal to 0 in for our logarithm. So if I ever am trying to do like the log of -1, I'm going to get some weird answer or I'm going to get an error, right? So let me go to my calculator. So if I try to take like the log of a negative number, I said not a number, okay? So not a real number. So this will technically spits back an imaginary number, and we're not going to talk about how to calculate that. That's well beyond the scope of the course. But it's not a real number. So this is not a real number, okay? So let's graph f of x equals log base 3 x plus 2 minus 1. Okay? Now, what's going on here? This inside here tells me that I'm going to go what? I'm going to go left 2. And this out here tells me to go up 1. Okay? So a log base 3 graph looks like this. I'm passing through at 1, 0. Okay? But what's going to happen? I'm going to take my graph, okay, and I'm going to shift it to the left 1, 2. Okay, so now I'm passing through negative 1, 0. And now I'm going to take my graph and I'm going to shift it down 1. Now, why I wrote up 1 here, I have no idea. This is down 1. Sorry about that. Okay, so I shifted down 1. So this point now is negative 1, 1. So I can erase the other two graphs here. Uh-oh. Delete. Delete. Delete, delete. And this is what my graph looks like. You've got a vertical asymptote here at x equal to negative 2. If I plug a negative 2 in, I'm taking the log base 3 of 0, which is undefined. In fact, anything. So up to this point, we've talked about a couple of things we can't do, right? We think about our red light, we have, remember, we've got red light, orange light, and green light, the 3 things you can't do. Number 1, you can't take a number and divide by 0, right? Dividing by 0 is a no-no, okay? Number 2, I can't take the square root of a negative. And the last one, we finally get to fill in that block here. I can't do the natural log or the log of a negative or 0. So I can't do it of a negative, and I can't do ln of 0. Those are undefined. Okay, so this ends up being the last of our what's not in the domain for college algebra, okay? So thou shalt not divide by 0. Do not take the square root of a negative number. Nth root where n is even. And then don't do a log or natural log of 0 or a negative number. Okay? Let's, one other thing that might help you is if you take y equals log base 3 of x plus 2 minus 1, and we did the exponential form, maybe that helps, maybe it doesn't, right? But if I add 1 to both sides, I get y. Oh, wait. If I'm going to do the inverse, first thing I do is I swap my x and my y. So I'll swap x with y, and then I'm going to solve for y. So I'm going to add 1 to both sides, so I get x plus 1 equals log base 3, y plus 2. How do I get rid of a log 3? I look at my base is 3, so I'm going to raise both sides to the 3. Cancel, so I get y plus 2 equals 3 to the x plus 1, and then minus 2 and minus 2. So y is equal to 3 to the x plus 1 minus 2. So if it helps you to graph an exponential, do it, right? So an exponential, you know, is going up like this, and it's shifted, right? You're shifting down 2, okay? So you're shifting down 2, and then this tells me that I'm shifting to the right or to the left. Positive tells me to go left 1. And then what do? Well, I have to reflect it, right? So I'm reflecting this about the line y equal x, and that's where this graph comes into play, and I get that -1 point there. Okay, so if it's easier for you to do it like that, great. If you'd rather just type it in the calculator, you know, that's a way to do it too, right? So how do you do a log base 3? Well, good luck with that if you don't have a smart calculator, okay? If you got a dumb calculator like me, so log base 3 of x plus 2 minus 1, you have to do change of base. It's log of x plus 2 divided by log of 3. Okay, that gets you this first part here. And then minus this. So that's how you'd have to do it. So you got to know the trick if you're going to use your calculator to help you out. So log of x plus 2 divided by log of 3 to get that base 3 factor. And then what am I doing? I'm subtracting 1. And so when I plot that, I see it there. Now it looks, I mean, the graph looks like, oh, it just cuts off. It just stops right there, right? Well, technically it doesn't. It's just dropping down so quickly that your calculator won't graph it. See, if you back off here, like it keeps going down. You just can't see it going down. Okay, it just goes down so quickly. All right, so that's what's going on there. So it's okay. It's still got a vertical asymptote there. So I might ask you, like on the test, what is this vertical asymptote here? So unless you know how to read this, then you're not going to know, okay, I can't plug in 2, or I can't plug in -2, otherwise I'm putting the log of 0, and that's bad. Okay, so that's kind of the trick you're going to use there for graphing your logs. Okay, let's do one more, log graphing. So we've got f of x equals log of 2 minus x. Okay, if I graph this, well, what's going on here? What's actually going on? Well, I'm replacing my x with a negative x. Okay, so my graph, that would be like log of x, right? But if I replace all my x's with negative x, what does that do? That takes a value that's over here at +1 for my x value and flips it to be over here at -1. Okay, so now all of a sudden I'm reflecting across the y-axis. Reflect across y-axis. Okay, I'm reflecting across y-axis. But then what am I doing here? I'm shifting, okay? So I'm shifting. So let's look at the graph of this, okay? So let's go here, quit, and then go up here. Let's do log of 2 minus x. I'm sorry, 2 minus x, not 2 minus 2. Come on now. Oh my goodness. Enter. So now you see how it shifted it, okay? So it pushed us over. Looks like we have a vertical asymptote at x equal to 2, okay? So instead of my vertical asymptote being at x equal to 0, my vertical asymptote looks like everything gets shifted over to x equal to 2. If I plug a 2 in, I get log of 0, right? So anytime I find log of 0, I'm thinking, okay, there's a vertical asymptote located there, right? So I've taken my graph and I've shifted it over. All right, I've shifted it over 2 units. So 1, 2. All right, so I'm passing through at 1, 0, just like this. Okay, so I hope that helps, because this one's really weird, because what's going on in here? My x is negative, so now to make sure that the log is positive inside, okay, I gotta pick values of x that make this positive. So that means 2 minus x has got to be greater than 0. Well, that's only true for x that's smaller, x that is smaller than 2. So that's like the opposite of my thinking. So x smaller than 2 are all these values over here. So it literally takes my log curve, which normally looks like this, and reflects it about the y-axis. Okay? All right, so hopefully I haven't turned you around too much. If all else fails, you can type it in your calculator. And then if you need to look at a table, all you have to do is second table, and you can pick out any values, that you may need if you need some other values. Okay? All right, good luck.